So, good day class. New topic for your machine design. We'll talk about pressure vessels. This is about thin-walled cylinders and the thick-walled cylinders plus thick-walled spheres. So, pressure vessels. When we are talking about pressure vessels, sir, ano po yung pressure vessel? Simply, they are containers of fluid, compressible fluid. Okay? That can be that can burst out kapag above tayo ng rating nila or lumampas tayo ng pressure rating nila. So, by definition, pressure vessels can either be cylindrical. Ano po ba yung cylinder, sir? Yung mga, sino meron dyang nakakain ng picnic, nakakain ng mga Pringles, yun, cylindrical yun. Mga tubo, cylindrical yun. Or spherical, ano po yung spherical? Spherical shell, yung mga bola, yan, sphere. Hydraulic cylinders, pipings, boilers, and water or air tanks used to hold liquids or gases under pressure. Hindi naman po, 'di ba sabi nila liquid and gas takes the space that it is contained. Takes the volume that it is contained. Oh, gaano man karami yung ilagay mo diyan habang pinupuno mo ng ipinupuno yung iyong container or yung inyong vessel, sisidlan, 'di ba? Yung inyong sisidlan, tumataas yung pressure rating niya. Nako-compress siya. So what happens? Habang tumataas yung pressure niya, ang material mo, hindi naman yan hanggang dun sa kanyang rupture level, it can hold the pressure. So kapag nalampasan na niya yung kanyang elastic limit, kung saan yung kanyang elasticity, okay? Kapag napuno niya yan, nalampasan niyo yun, makikita niyo dun sa curve na yun, pag nalampasan niyo yung elastic limit niya, your material will never return to its original state. Okay? Ibig sabihin, magkakaroon ka na ng breakage. Magsisimula na dyan yung failure of your material. Sir, ano bang pag-uusapan talaga natin sa pressure vessel? It is the ability of your vessel. Pag nagdi-design ka, from the word itself, machine design, pag nagdi-design ka, your vessel should contain the required amount of the liquid without exploding. Yan po yan. It can be classified in two parts and two types. Number one, thin-walled. From the word itself, thin-walled, manipis. And then thick-walled pressure vessels. So how can we say that is thick-walled and thin-walled? Simple. A pressure vessel is considered to be thin-walled when the ratio of the wall thickness T to the inside diameter is equal or less than 0.07. And anything beyond 0.07, the ratio of your thickness and your inner diameter, you can say that it is now a thick-walled pressure vessel. So, bago ka po mag-solve ng pressure vessel on its bursting pressure or the stress of bursting, i-check mo muna if that is correctly, okay, within the boundaries ng ratio na 0.07. If that encompasses it, or kung pumasa siya doon sa ratio na yon or mas mababa siya or equal, you can say it is thin-walled. If not, that is thick-walled na. So, dalawa po ang uri ng equation natin pag thick-wall and thin-wall. Okay? But we note, the stress analysis for this class of vessel is based on simple stresses only. Okay? Or if the stress is uniform in distribution. Okay, let us go with cylindrical thin-wall pressure vessel. Sir, ano po ba yung cylindrical? Again, in your going back in your solid mensuration, cylindrical pressure vessels are those which has a head or a base that is circular. Okay? Circular ang bases mo. And that is stretched to an element or a height that is perpendicular to it. Okay? So, kapag gumawa ka po ng pressure vessel, it does not come simply. Hindi siya cylinder kagad. Okay? Kapag malalaking pressure vessels, it will come to a thin sheet of metal that is formed into cylinders, into spheres. Okay? And that material will have a certain thickness. Okay. And yung thickness na yun, that is based on the bursting pressure or the amount of pressure that it will contain. Hindi po tayo pwedeng maglagay dyan ng material that will not pass through the test kung saan gagamitin natin siya. Now, let us talk about the tensile stress at section AA. A to A, itong section na to. Okay? Anong tawag dyan? Longitudinal ba? Anong tawag sa B? Is that it? Is that latitude? Okay? Latitudinal, no. Horizontal or vertical, longitudinal or tangential. Pag-usapan natin yan mamaya. Now, if the stress is at section AA or horizontal, we call that the tangential stress, the transversal stress, the circumferential stress, the hoop stress, or the girth stress. Mostly, ang topic natin dito ito. Ito yung ginagamit parati sa mga problems. The tangential stress and the hoop stress of the material or of the vessel. Bakit naging ganun, sir? Tignan nyo. Yung hoop, di ba? The hoop. Hula hoop. Yung hoop na yan, that is the one na yung bumabalot sa buong cross-sectional area mo. Okay? That is the hoop. Yung hoop na yan, yan yung bumubuo ng cross-section kung saan nandun yung iyong face. Okay? Tangential, ibig sabihin, your stress will touch only one point on your outer boundaries. And we call this as the maximum stress that a vessel can contain. Bakit po? Bakit maximum, sir? Kasi ang baba ng inyong divisor, which is twice only of the thickness of your pressure vessel. So, pag sinabing maximum stress or the tensile stress, other terms could be tangential, transversal, circumferential, kasi within the circumferences, the hoop stress and then the girth stress, the maximum stress is equal to PD over 2T multiplied to NJ. What is NJ? NJ is the weld efficiency. Or simply, pwede rin niyang joint efficiency. Okay. Commonly, kapag hindi binigay sa problem, we assume this as 100%. Pag binigay, ipasok mo yung value that it is given. Bakit sinasabing weld efficiency? That is how yung niya, the rating, okay? The rating ng kanyang joint and weld. The next one, the tensile stress at section B to B. Ano po bang tawag dyan? Longitude. Pagpatayo, longitude. And that is the minimum stress that your pressure vessel can contain. And other terms that is used, longitudinal. Okay, tandaan nyo, ang pinakamaraming term na gagamitin dyan or pinakamaraming terms na meron ka is the maximum stress, pero longitudinal or pinakakonti, syempre minimum. Kaya nga maximum, ang dami mong tawag sa stress na yon. Pag minimum, may isa lang at kukunti. And titignan nyo, if this is minimum, mataas yung divisor niya, which is 4 times of the thickness ng inyong material. Okay? Where both P and D, ito is the internal pressure that is contained inside your pressure vessel, and D is the internal diameter or inside diameter. Given by the formula, ST is equal to PD over 40 NJ, where NJ is weld efficiency or the joint efficiency. We note that the stress at section AA is greater and thus in designing cylindrical pressure vessel, pag nagdi-design ka, okay, the design stress is always on the maximum stress that your pressure vessel can contain. Hindi ka po pwedeng mag-design dun sa minimum. Okay? Bakit? Kapag minimum yan, kapag lumampas dun, sabog yung pressure vessel mo. Kailangan you always design for the maximum value that it can contain. Okay? So, this is the formula for your design stress. The design stress is also the maximum stress, tangential, transversal, circumferential, hoop, and girth. Okay? Now, let us go with the spherical thin-walled pressure vessel. Spherical, from the word itself, is sphere. Okay? Sir. Merong other formula. Paano natin makukuha yung formula po ng ating volume dito? Minsan, volume ang binibigay, di ba? Di ba? Oh, from thermodynamics, if an ideal gas is contained inside a cylinder, ano po ang dapat nating gamitin dyan? Sinabing ideal gas, you'll go with ideal gas law. What is ideal gas law? To remind you, that is PV is equal to MRT, where the mass is contained inside the cylinder and after compressing it, meron kang temperature, meron ding pressure and volume. But the given there sometimes is volume. Okay. Volume is given in terms of the volume that is contained inside the cylinder. And sabi ko that gases and liquids take up the space that it is contained of. Okay. So the volume, kunwari, pag cylinder, okay, going back to your solid mensuration, the volume of a cylinder is pi r squared h. Or the area of the base times height. Pasok nyo dyan. Okay? You will encounter problems na meron kang nakahalong thermodynamics, which is very basic. Okay? Now, the spherical thin-walled pressure vessel. Sir, hindi ko rin maalala yung volume niyan. Very basic kapag solid. Okay? Kapag spherical or sphere, that is equal to 4/3 pi r cube. How about naman kapag diameter are given? O, divide mo lang yan to eh. 1 or pi/6 d cube. Very basic lang yan. And always, okay, kapag spherical thin-walled pressure vessel, wala naman yung haba or girth. 'Di ba? Wala yang neck. Okay? Pag walang neck, mas mahina po ang kanyang bursting. And that is always equal to, in any section where you will measure the pressure that is contained there, the design stress or the tensile stress of every spherical thin-walled pressure vessel is equal to P/4T tapos yung joint efficiency. Sometimes yung joint efficiency is E. Okay? Small letter E. Now, napakadali naman sir kapag thin-walled. How about yung ating thick-walled pressure vessel? Now again, for thick-walled pressure vessel, the ratio of the thickness of your plate to its inner diameter is greater than the ratio ng 0.07. You can say it is thick-walled. You can say it is thick-walled. Now, we note that the stress distribution is particularly weak at its section and it is not uniform. Okay? Now, pag thick wall, there are different equations na binibigay dyan. But the most prominent is the one that is given by Lam's equation. So, according to Lame, okay, sabi nga dito, particularly weak. Ano ba ang other word for weak that is lame? Lame lang pa, di ba? So, you'll use lame's equation. So, that is piri, poro, pipo, rori, overori, rori. Ganun lang yan, ha? Sir, para ma-memorize natin kagad. That is piri, poro, pipo, rori, overori, rori. Ayun. Napaka-basic. Lahat ng R dyan, lagyan mo po ng squared. Ano lang. Diba? Kaya, piri, poro, pipo, rori, over, rori, rori. Very basic. That is given by Lame's equation. Sir, diderive mo po yan. Loko-loko. Ang haba niyang derivation yan. But we have to memorize na lang siguro. But kahit kumikit ka dali naman tandaan eh. Piri, poro, pipo, rori, rori, rori. Tatlong rori. Diba? Paano magiging plus and minus? Kapag naging plus yan, if ganito, yun sa Lame equation, this is maximum stress. Kapag negative, that is minimum. Okay? Sir, depende yan kapag sinabing axial, tangential, and radial. If that is axial, okay, ang kukunin mo lang is this one. So, di ba yung Lame's equation now, or the total stress, or maximum, lagay mo, maximum, is equal to yung axial stress plus, ano pong tawag dito? Okay? Plus, pipo, rho, ri, over rho, tapos minus ri. Anong kinuha mo dito? Okay? Kunin mo yung pag tangential, 1 over. Depende yan ha, inside or outside. Ito, Rx ko na lang to. Squared. Tapos lagay mo dito, squared, 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 squared. Depende kung anong kukunan mo dyan. Kapag kinunan mo, ang binigay dyan is inside. Okay? Inside. Kapag binigay dyan is outside, outside. Okay. Magiging maximum kapag plus, minimum kapag minus. If tangential, tandaan nyo, pag tangential, that is maximum. Kapag radial, that is minimum. Paano po nagiging minimum yan? Okay, R. Ito yun sa R dyan. Yun sa Rx. Okay? Rx, i-consider mo yung Ri if inner surface of the cylinder is considered. And Ro, if outer surface of the cylinder is considered. If the vessel has no external pressure na sinasabi, the above equation for tangential stress can be expressed as taking yung R is Ri. Pag hindi sinabing hindi sinabing tangential, pag hindi sinabi rin na external, wala kang external, Ri ang kukunin mo. But first, you have to check for the thickness. Minsan, kinukuha mo muna yung thickness dyan eh. Given yung tangential and yung inside. How will you do it? T is equal to D over 2 bracket multiplied to the square root of the sum of ST plus PI over the difference of yung square root ng sama ng ST and PI and then the difference of ST minus PI minus 1. Okay? Tangential or maximum. Maximum pressure yan. Or maximum stress na kaya niya. Ano po ang maximum? Tangential. Ang minimum, that is radial. And then yung nasa unahan, piriporo, that is axial. Okay? Ganun lang po yan. But, lo and behold, mas magandang ipasok natin sila sa problem para mas maintindihan natin. I have here yung index ko na sinamari ko na lahat ng kailangan mo. Now, 14 volt, dapat mas mababa siya sa ratio ng 0.07. Binago ko na ito. Pag ST, sabi dyan, that is maximum. SL is minimum or tangential, longitudinal yung SL. Pag spherical, pareho lang yung tangential and longitudinal kasi it is a perfect circle. Now, for bursting, pag sinabi yung mga bursting pressure problems, kailangan kunin mo yung design stress and the ratio niya dun sa internal stress, equate mo dun sa tensile that is given and then the bursting pressure in order for you to get either of the bursting or the design pressure. Now, for thick wall, always, ang piriporo yung nasa unahan is the axial stress. The radial stress is the minimum pressure. And then the tangential is the maximum pressure. Sinabi sa problem, determine the maximum pressure of a thick-walled vessel designed to have the following parameters. Sinabi naman, design the stress or determine the stress of the following thick-walled pressure vessel designed to have the following parameters. Okay? Now, for Lame's equation, ito na yung binigay dyan. We note that STI or the tangential stress measured on the outside minus on the inside is equal to, laging mas mataas yung pressure stress on the inside kaysa sa outside, equal to P po, or the pressure inside and then the pressure outside. Okay? Sinamari ko na. And for problem number 1, a thin-walled cylinder is 15 inches in diameter. The internal fluid pressure in the cylinder is 150 psi. The wall thickness is 0.125 inch to. Find the induced stress in the cylinder wall. So, ano ba sinabi dyan? Walang sinabi if maximum or minimum. So, you always have to determine you always have to assume that it is in maximum. So, ST is equal to P D over 2T E. O, may sinabi bang E dyan? Wala. So, you assume that it is 1. So, internal pressure is 150 psi. The diameter internal is 15 inches. Twice of the thickness, which is 0.125 inch, multiplied to 1, which is wala namang binigay na joint efficiency. We cancel all the same units. Yung inch and then inch. Natira is pound per inch squared or PSI pa rin. So, we calculate the value. 150 times 15 divided by 2 times 0.125. The answer is 9,000 PSI. Very basic lang yan. 9,000 PSI. Next problem. A spherical pressure vessel has a 480 millimeter diameter. The internal pressure is 10 MPa. You determine its wall thickness. The allowable stress in the material is 80 MPa. And the joint efficiency is 80%. Ngayon, ano dito ang design stress mo? Ito yun, no? Sinasabing allowable tensile stress. This is the design stress. Spherical na to, so you will assume that it is ST is PD over 4TE. Ngayon, anong hinahanap dito? Yung wall thickness. So, we reform the equation, cross-multiply. So, T, thickness is PD over 4STE. Okay, we can solve for the value of T, where T is equal to P. Ano ba yung binigay sa'yo dyan na pressure internal? That is 10 MPa multiplied to the diameter, that is 480 millimeters, divided by 4 times ST, that is 80 MPa, divided by joint efficiency is 0.8 kung di ako nagkakamali. Ayun, 0.8. So, very basic again. Yung thickness niya is 10 times 480 divided by 4 times 80 times 0.8. The answer is 75/4 or 18.75 mm. Very basic pa yung mga problems natin dito. Another one. A boiler tubes with diameter of 50 millimeters, internal diameter, are used for handling 20 MPa of steam. So, yun. Ito na yung internal steam na hinahandle niya. Determine the thickness of the tubes necessary for an allowable stress of 80 MPa. Assume the joint efficiency is equal to 1 kasi wala naman binigay. Okay? Thickness again. Thickness is PD over 4 ba yan? So, allowable stress, laging design stress. Hindi po yan 4, lagi yang 2. Pag design stress, that is the maximum stress. Okay? That is 2 SDE. So, the thickness is equal to P, internal pressure of 20 MPa, as diameter, which is 50 mm, divided by twice nung SD, 80 MPa, tapos 1. Cancel the same units, you'll arrive with the answer. So, 20 times 50, that is 1,000 if correct ako. Tapos, 2 times 80. So, that is 6.25 millimeters of thickness. Very basic talaga. Another one. A 60-inch diameter steel pipe, a 8-inch thick carries water under a pressure head of 550 feet. O yan ang problema mo. Determine the hoop stress in the steel. Hoop stress is simply maximum. Okay? Binigyan kang diameter, binigyan ka ng thickness. Ngayon, pag binigyan ka una niyan, you are always to find out if it is thick-walled, okay, or thin-walled. So, T over D, tignan natin if that is less than or equal to 0.07. We check first, okay? Yung thickness niya, that is 3 over 8, tapos 60. Equal to. Tignan natin kung that is less than 0.07. So, this is 3 over 8. Lagi mong gagawin yan, ha? Over 60. If that is less than 0.07, that is 0.00625. Ibig sabihin, this is less than 0.07. Check. Less than 0.07. Therefore, it is thin wall. So, ano nga hanapin natin dyan? Meron tayong pressure head ang binigay sa'yo. The internal pressure is, hanap dyan? The hoop stress. Ayan. Internal pressure is in heads. In head. Sir, hindi ko na matandaan. Oy, nag-fluid mechanics kayo sa akin. Madali lang i-translate yan. Ilang meters of water? Carries water. Ayan, water. Naka-pressure head ka. So, ibig sabihin, head, okay, is equal to density ng water. Hindi. Pressure over, ano to? Density ng water. Ito ang kinukuha mo. Okay? Ibig sabihin, the internal pressure there is yung sa water, specific weight of water, multiplied to the height ng water. Very basic po. Masosolve na natin yung hoop stress. So, the maximum stress is equal to Pi di over 2Te. Maximum eh. Where pressure is in terms of head. Sa water, multiplied to the head, multiplied to di over 2Te. Okay. Okay, hindi ko na matandaan, sir, yung sa water. Sa water, that is equal to 62.4 or 64.2. Sige nga, nililito ko kayo. Pound per feet cube. Yan yung specific weight of water. If you can remember. Okay? 62.4 pound per feet cube. Sir, hindi ko pa rin tanda. Pwede rin naman 9810. 9810. Kilonewton per meter cube. Kaya lang magko-convert ka pa. Ito, direkta na eh. Okay? Yung head ng water, 550 feet. Tapos DI, in diameter, 60 inch. Over 2. Yung thickness, this is 3/8 inch. And then the joint efficiency is, binigay ba dyan? Wala. So, 1. Ang problema mo dito, dapat in PSI. So, meron tayong conversion factor dyan. That is 1 feet squared per 1 feet squared per 144 inch squared. We cancel all the same units. Yung feet squared, inch. Ang lalabas is pound per inch squared. We can calculate for the design stress or the hoop stress. So, 62.4 times 550 times 60 divided by 2 times 144 times 3/8. The answer will be how many? How much yung stress niya? 19,000 PSI. So, 19,066.67 PSI. That is now the hoop stress. Next problem. Very basic lang yan, no? Very basic. A round vertical steel tank. Round vertical, ibig sabihin cylindrical. Has an inside diameter of 3.5 meters and a height of 7 meters. Problema, binigay sa iyo volume. It contains gasoline with a density of 740 kg per cubic meter. If the allowable tensile stress, meron kang design stress dyan, determine the minimum thickness required. Minimum ha? Minimum. So, binigyan ka ng allowable tensile stress. Hindi sinabi sa'yo minimum. Okay? Minimum. Saan mo kukunin yung minimum? Sa maximum ba or sa minimum stress? Dalawa ang pwede mong pagkunan yan. But first, you have to put the equation. So, design stress is equal to P D over 2T. E. O ngayon, vertical steel tank. Binigyan ka ng height and binigyan ng inside diameter. Problema mo dyan, yung internal pressure. Okay? How will you get the internal pressure? Sige nga. Binigyan ka ng volume. Okay? So, the volume of the cylinder. Ang problema mo dyan. Meron kang kilogram per meter cube. Meron kang density. Okay? So, makuha yung pressure. Sige nga. Tignan dito mass over volume. Pwede natin tong gamitin as para makuha natin yung mass niya ba? Sige nga, mag-isip tayo. This one, Okay. May binigay ako ditong problem sa power plant design. Okay? Yung, tawag dito, yung power plant, integration course to power plant design. So, I'll have you 5 minutes to think about it. Okay? Then, I'll have your comments. So, itutuloy ko siya after 5 minutes. Okay? Isipin nyo muna kung paano gagawin nyo. Kasi yung example ko dito is water. Okay? Binigay ko yan sa topics 3. Water ang example ko, binigay inside diameter and then the height. How will you get the pressure? Okay? You just have to think about it for 5 minutes. I'll have to take a break. Iinom muna ako ng tubig. Okay? And then, let's continue. Okay, so naisip nyo na kung paano ang gagawin ni Sir? Ha? Napaka-basic niyan. Okay. We can, let me just open ko lang to. Okay. Yan. So, very basic. Okay? Kahit ibigay sa'yo dyan, okay, elixir of life na liquid, the same process that you will do. Dadaan ka pa ba dito sa mass over volume? Can be. Pero ang pinakamadali dito, that in your, okay, fluid mechanics, lahat naman kayo nag-fluid mechanics natin. Remember that pressure in a cylinder or in a tank is always given by the density of the material or the substance multiplied to the height it contains. Okay? Tandaan nyo ba yan? Tandaan nyo pa? So the internal pressure will be equal to the pressure equal to the specific weight of the material or the substance multiplied to the height it contained. Okay? So, ang tumataas, di ba tumataas ang pressure? Okay. No matter what the volume of the tank will be. So, binigay sa yung design stress dyan. Anong inaanap natin? The minimum thickness. So, reform the equation like this one. P D over 2, the design stress, times T. Minimum thickness ha, titignan natin kung nasaan ba yung minimum thickness. So, dalawa yung operation na gagamitin natin. We could use this one. We could also use this one. PD over 4TE. Ano yung minimum thickness dyan sa dalawa? Pero kung ako, titignan ko lang, alam ko na kung nasaan yung minimum thickness. Okay? Pero papakita ko na lang sa inyo kung paano din. So, the thickness is yung pressure given dyan yun sa gasoline. Okay? So, 740 kilogram per cubic meter. The problem there is, ito. Ano ba ito? Diba that is rho times G? Multiply mo ng gravity. 9.81 meter per second squared. Magiging Newton per cubic meter to. Okay? Tapos, multiplied to diameter. May diameter mo dyan. 3.5 meters. 3.5 meters. Tapos, meter. Okay? May Newton to. Pag pinagsama mo, may masosobrahan ka lang dyan na Newton per cubic meter. Okay? Tapos, 2 SD is Newton per millimeter squared ko na lang. 28 Newton per millimeter squared multiplied to 1. Okay, cancel all the same units. Magiging Newton per millimeter cube to. Meter cube. So, dapat dito, millimeter lang ang matitira. E di multiply ko na lang yung isa dito ng 1,000 millimeter in every 1 meter. Okay? Newton na rin naman yung nasa taas. Okay? So, this will become 740 millimeter squared. Dapat mga millimeter squared yun nandito. Tapos meter. Tama ba? Density times height. Kulang pa ako ng height. Ayun, nandito na pala. 740 times 981. 9.81. Newton per kilogram meter Newton per meter cube. Tama. Tapos cancel yung meter. Ayun, baliktad pala. Baligtad ako ng lagay. Dito. Maging meter cube dapat. Newton, meter cube. Ba ako nagkamali dyan? Height. Tama, 7 meters. 3.5 ang ginamit ko. Yun, yung height pa pala. Kulang pa ako ng height na 7 meters. Ayan. Nahanap ko yung height eh. Naduduling na ako eh. 740 times 981 times 3.5 times 7 divide by 2 times 28 times 1,000 millimeter na matitira dyan. So, the thickness will be 3.176 millimeters for the thickness. Hindi pa natin sure ha. Pwede rin kasing gamitin ito, 40E. Pero laging ang minimum thickness mo dun sa greatest or sa maximum pressure na meron ka. Okay? So, that is now the value. Next one. Determine, meron pa ba? So, ilan pa yan? Dalawa pa. Determine the safe wall thickness in millimeters of a 50-inch steel tank with an internal pressure of 8 MPa. The ultimate strength of the plate material is 296 MPa and the factor of safety to be used is 3. So, SD. Okay, laging ganito. Factor of safety divide by mali pala. SUS divide by factor of safety. Yan. Check. That is SD. Where ang hinahanap dito, safe wall thickness. Okay? Safety to be used is 3. Ibig sabihin, the distance ulit. Design stress is equal to PD over 2TE. Okay. Where SD is SUS over 3. Or the factor of safety. O ngayon, ang hahanapin natin dito is safe wall thickness. Cross-multiply na lang natin. So, safe wall thickness now is T equal to PD multiplied to FS divide by SUS 2T 2E. Thickness is equal to P. Ang given internal pressure is 8 MPa. In diameter, that is 50 inches. May conversion factor naman tayo dyan to millimeter. So, 25.4 mm is equal to 1 inch. Factor of safety is 3. Divided by 2. SUS mo is 296 MPa times 1. The safe wall thickness now will be, tignan natin kung tatama, 8 times 50 times 25.4 times 3. Ano ibig sabihin ng factor of safety mo? Ibig sabihin yung design stress mo is thrice. Tatlong beses niyang kayang i-carry. Or, a third of your ultimate stress yung kaya niya i-carry ng material. Tapos, 2 times 296. The answer is, ilang millimeters? 51.4865 millimeters. The thickness is equal to 51.4865 mm. Approximately, pag nagsa-sizing ka, okay, 51.48, hindi na, 51.5. Pag sizing, wala namang kasing 0.48 na measurement. Ikaw na ang gagawa niyan kapag nagde-design ka or kapag ikaw magbi-build, ikaw na ang gagawa ng minor adjustments. So, the last one. A cylinder having a diameter internal of 50.8 cm and an external diameter, problema mo dyan, is subjected to an internal pressure, internal ang binigay, and an external pressure of 26 MPa. Determine the hoop stress. Ano po ba ang hoop stress? That is the maximum stress at the inner and outer surface of the cylinder. So, inner and outer, gagamitin mo sa R mo, binigay dito dalawa, Ri, gagamitin mo, yung Ro, gagamitin mo rin sa dulo. So, ang pinag-uusapan natin dito, hoop stress or maximum. So, that is equal to, yung design stress mo is equal to P, Ri, Poro, over, Rho, Ri. May natin lagay yung mga, maximum yan, kaya plus. P po, Rho, Ri, over, Rho, Ri. Naka-square yan. Minus, square, 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 minus, square, multiplied to 1 over Rx squared. Kaya lang sa Rx, kukunin natin itong dalawa. To solve natin separately. So, SD. Yung P, internal pressure of 103 MPa. 103. May natin yung unit. Newton per millimeter squared. Ri, MPa. Ri, ano dyan binigay niya? In mm mo na lang. Pwede rin naman kahit di mo na i-convert. Pareho lang naman ang unit. Internal, that is 50.8 cm squared minus poro, that is, pag mahaba, tuturuan ko kayo ng technique dito. External, that is 26 MPa. Tapos, 91.44 cm squared. Part by part ka mag-solve. Okay, first part ka muna. So, first part, Rory, that is 91.44 cm squared minus Ri, 50.8 cm squared. Tapos, dulo, plus, Pipo, 103 minus 26 MPa. Rho, that is 91.44 cm square mo. Tapos, 50.8 cm squared over Rory. That is 91.44 cm squared minus 50.8 cm squared. Tapos, multiply mo yung dulo. 1 over Rx. Unahin ko muna yung Ri. Una muna yung Ri natin. Inner. So, Ri, diameter pala to. Divide by 2 na lang natin to. Okay? Tingnan natin. So, 50.8 divide by 2. Purahin ko muna lahat para hindi ka nalilito. Diameter pala yung binigay dyan. Hindi ko nabasa. Yan. 91.44 divide by 2. 91.44 divide by 2. 50.8 divide by 2. 91.44 divide by 2. 50.8 divide by 2. As Rx squared. Dito, 91.44 divide by 2. 50.8 divide by 2. So, how will we do it? Very basic. Sir, sir, meron sistema dyan. Okay. Yung SD mo, ito yung technique para hindi ka nalilito. Papalit-palit ka na ng value. Okay. Going back here. Yung P I, set mo as A, alpha A. Yung PO, set mo as B. Yung RI mo, set mo as C. Yung RO mo, set mo as D. Saan po, sir? Sa calculator mo para hindi ka nalilito. Okay. Ganito yan. PI, Piri. So, alpha A, alpha C, minus, square mo muna yan, minus, alpha B, alpha D square. Divide mo ng, yung Rory, C and D yan, alpha C squared minus alpha D squared. Plus, yung ulit, okay, Pipo, alpha A minus alpha B multiplied to alpha C squared alpha D squared. Okay. Baba naman, alpha C squared minus alpha D squared. You just have to take notes. Okay? Take note mo muna yung mga given dyan. Tapos, ipasok mo dito sa equation. So, 1 over, depende na lang, alpha x ko na lang. Pwede mo naman gawin dito kung ano yung susundin mo. Laging yung dulo x mo kasi pwedeng palitan mo internal or outer surface. Kapag internal lang ang hinahanap, do internal lang ang gagamitin mo, internal diameter, internal radius lang. Kapag sinabing outer surface, outer radius yung hanapin mo. So, you press calculate. Yung value ng A mo is PI, which is, saan dyan? Internal, di ba? Internal pressure, PI. That is 103. Oh, yung B. Yung C, mauna yung C. Ito yung RI. Ano ba yung RI mo dyan? Inner. Internal diameter. So, yan yung 50.8 divide by 2. Yung B, that is PO, outer pressure or external pressure, that is 26. O, yung D mo, that is 91.44 divide by 2. 91.44 divide by 2. Now, the dilemma there. Okay? Yung X mo, unahin ko muna si X. Si X is yung inner surface, ha? Ang gagamitin ko dyan si 50.8 divide by 2. So, we calculate the value. Tignan mo yung value niya ngayon. Negative ba? Oh, bakit naging ganun? Saan ako nagkamali? Dito. Hindi ko na-square. Yun. 119.75. So, SD is equal to 119.75 MPa. Kapag outer naman, calculate mo ulit. Okay na yan? 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 Yung X na lang ang babaguhin mo. X babaguhin mo is dapat outer surface. That is 91.44 divide by 2. The answer will be 42.75. Very basic. This is inner. SD 42.75 MPa outer. Okay? Ganun lang po yan. Now, that wraps up the discussion for our pressure vessels. If you've got questions, feel free to ask. Ito na po yung pinaka-technique kapag gagawa kayo ng calculation ng thick-walled pressure vessels. Okay? That wraps up the discussion.